this much amount of emission into the atmosphere. That is logged. That's all. You can't change that. Once you complete your building, you can't change the embodied carbon of your brick, embodied carbon of your incorporated concrete, steel, anything. It's logged there itself. But regarding the operational carbon, we can do some adjustments. Like if you are putting some like uh, wind, what to say, windmill kind of thing, right? So then you may choose solar panels. Nowadays we have a lot of schemes supporting for our solar transition. So by doing those things you can compensate that operational carbon to some extent, or you can 100% compensate with, you install 3 megawatt, or 6 megawatt or 9 megawatt. You can compensate the entire operational carbon which is associated with your building. But embodied carbon, it's not the way. Once you purchase a brick, that's it. You consumed that amount of embodied carbon. So how we can address that embodied carbon then? So before buying a brick, we should understand what kind of brick it is, what are the ingredients, made up, using were used to make up this brick, how I can go for the alternative. So all these things we have come across in UG projects, PG projects, or even PhD projects. But in real, in market, for example, there would be some new IT park are being built across Chennai or across Bangalore and any high tech city. So what happened? What is happening with those current projects? Who is taking care of those things? Whether it is green building certified or not. If certified, what are the strategies they took over to make that building as a green certified building? So all those things very matter than providing continuous projects to the students without understanding what is really happening, right, in the market. So the built environment, as I mentioned, it's constitutes with embodied and operational carbon. Embodied carbon constitutes with the extraction, manufacturing, transportation, and installation. Whatever the material you take, whether it's a steel, brick, cement, fly ash, anything, right? That comes through all those phases. And during the construction, it is being installed. Then, once it is over, the building gets started, gets utilized till the end of life, right? So the entire picture comes as whole building life cycle carbon. So now, for choosing a carbon efficient foundation or slab or column, we should approach the building from the perspective of whole building life cycle, not like some material based understanding, right? That won't help, because the entire system we have to understand, and from that perspective only we can able to uh, get the benefit of integrating, within the modules or within the components of the building. For example, if you construct a building and you already made the frame, right, like column and beams, everything you made. After that you got understanding of this carbon and all, then you can still make the change with respect to the slabs and the stairs and other walls, right? That's the concept of whole building understanding. So before you start designing your BIM model or a Revit model, you should have the conscious of this carbon load, so that you can come up with better building design. So we have different options mentioned as pathways, so that we can decarbonize these built environment. If you take embodied carbon, if you take operational carbon, or during the construction, we have different options. Like if you take embodied carbon, responsibly produced materials. That's one of the thing. I don't want to explain all these things here. Materials with recycled content, then low carbon materials through R&D, which is the ultimate backbone of all these things. That will happen continuously in the background, right? Then during the construction, like perspective, the designing, then preferring carbon negative or carbon absorbing materials, then working with green procurement policies. So the policy also gets weightage in the green designing of foundations or any buildings. Right? Policy should be there. For example, newly there has been one newly constructed IT park has been opened in Chennai and Coimbatore recently by our respected chief minister. So there in that construction, the PWD or whoever the top authority would give the work to the subcontractors, contractors. That's how the government functions. So when they give the contract from the very top hierarchy to the planner or constructor, they should intimate them to have this green procurement policies with them, so that only they can submit the tender and they can able to participate in winning the tender. So there, that particular policy based placement lies with the powerful authority. If the powerful authority misses to place such policy in the very top place, then the contractor or subcontractor may not able to follow that with the intention of producing or constructing a green building environment, right? So policies really matters. So with respect to the operational carbon, as I mentioned, you can utilize renewable energy sources like wind and solar. Then you can use water efficient faucets across your building points so that you can minimize the water usage. And still you can grow some greenies along your facades so that you can help in carbon sequestration as well, so that you can manage or complement your operational carbon. So all along with that, across from embodied to operational, the common or broad solution is nature-based solution application. Right. So in all these phases, we can apply that ideology, nature-based solutions. That's a very broad, very broad perspective. It's like imitating nature, biomimicry. People used to say, right? So this is what we are going to talk about, that embodied carbon, right? So first we should know what is embodied carbon. So if you talk about the definition, you don't worry about the right side picture. Let me explain that. Embodied carbon of a building, it's like total amount of CO2 emissions associated with all these phases. Production of that material, like including extraction, transportation, and all those things. Then further transportation from the factory to the site, and in the site it is being installed or constructed. Then once the construction is got over, there will be some maintenance like replacement, refurbishment, renovation. All those things will be there. Then finally, disposal of that material. So embodied carbon is not only like up to the manufacturing plant. It also expands into the operational phase as well, but still with limited scope coverage. So, who gives authenticated definition for calculating embodied carbon and operational carbon separately? It is from EN 15978. That is European standard, which is being followed universally for constructed environments like building or any infrastructure elements. So embodied carbon encompasses all the emissions generated throughout the material's life cycle, A1 to C4, except B1, B5, B6. So what are that A1, all those things. So we might have heard about one term in life cycle assessment, boundary condition. Like cradle to gate, cradle to grave, cradle to cradle, gate to gate, all those things, right? Same thing, it is being further, cut down into individual modules. So if you see the A module, it is A1 to A3 is nothing but cradle to gate, right? So once the product is being made in a factory, that comes like cradle to gate. From the gate, it goes to the site, right? So that is nothing but the transportation comes as A4. Once it reaches the site, further being installed or constructed at the site. So it may require some further energy input, right? So that regarding related emission comes under F5. So altogether, A1 to A5 is meant for from the cradle to the construction completed stage. Once the construction is completed, then we are entering into the B models. Like B1 is use, B2 is maintenance, B3 is repair, B4 is replacement refurbishment, B5 energy use, B6 water use. So here we can't impact this B5 and B6 because they are separately meant for operation energy consumption for the building and water consumption for the building, right? So that only here it is mentioned except B1, B5 and B6. B1 is nothing but use phase, right? That comes under operational carbon concept. Then once the entire life cycle of 40 to 50 years got over within B1 and B6, we enter into C module. C module is nothing but further options, whether you are demolish it, whether you may, ultimate thing is with respect to a building, it is demolition, right? So once you demolish it, during the demolition you spend some energy and contribute some emission, that is C1. Once the demolished product is getting transported, that is C2, transported to where? To a processing site. At the processing site, some emission is there, that is C3. Finally, ultimately, it is getting disposed to the landfill, that is C4, right? So entire C1 to C4 is meant for end of life stage. So we are all, coming up with our own building construction, right? Like our dream home. So when we have such opportunity, we used to think upon how the building is going to look like from the outside, how it is going to be inside. Everything we used to imagine and design, and we used to ask the constructor or the local masons, all those people, but we never imagined or we never planned for the end of life stage of our own dream home, right? Because that's not going to come, that may not be going to come in our lifetime. It may happen after 40 years, 50 years. I am not going to be there. My son or daughter or somebody else would be there. So that's their responsibility. But this life cycle approach, whole life cycle approach, insist you to think about that end of life stage as well. So what people are telling, if you are thinking about end of life stage of your future building, please design the building which supports dismantling options, not demolition options, dismantling options. So that if the wall is making a problem, you remove the wall alone. If the roof is making a problem, you remove that particular slab alone. Like how we are removing a broken tile in our flooring or walling and replace that single tile alone and replace with the newer one. Similarly, you try to design the entire construction of your building, like that people are telling, right? That is being under consideration in the European continent and American countries. And Elon Musk has already introduced that kind of concept with his portable and easily made modular house units, right? But for their climatic conditions, those materials, wooden materials, are highly compatible. But with our temporal climate regions, like India, this side, Indonesia, Singapore, all those places is not that much quite comfortable with that. Even Europe is experiencing 40 plus degrees these days. So European also they are worrying up with how to make their timber buildings more energy efficient or more comfortable. But still Americans are enjoying their own cold climate, so they are coming up with those kind of things. But this is the fact you all should understand. The end of life stage of your building also should be considered while you are planning it, right? So that's the thing. Embodied carbon not only with cradle to gate, it also expands till the end of life, right? That is what I wanted to mention here. So how to calculate embodied carbon? So we have to collect the data. We have to convert the data into CO2 equivalent and calculation of total embodied carbon, then normalization of results. So this is the basic and ultimate steps. So what are the data you should collect? Energy use and emissions regarding what are the raw material being extracted, manufactured, transported, constructed, like material, how much material it took, how much energy it took, like inputs. Like for example, for a brick, or for a very fundamental unit, for a brick, I use 1 kg of clay, 1 kg of sand, 2 kg of fly ash, or 3 kg of cement, all those things. That is material input. How much energy you give. So I processed everything with some manual mixer or mechanized mixers, means how much electricity it spent. That is the energy input, right? So some 2 kilowatt, 0.75 kilowatt, like that, some number you are there. So material input is there, energy input is there. Okay, with all these inputs, what are the outputs you emit into the atmosphere? So CO2, this much amount got emitted, this much methane got emitted, this much that gas, this gas, all those nitrous and other things. Some gaseous emissions will be there. Sometimes waste also would be emitted. So, as a solid, some waste material would come out. As a gaseous, some emissions would be come. So, those are all the ultimate data that you should collect for calculating the entire, embodied carbon of a particular product. Material input, energy input, gaseous output, waste output. That's all. So now you have to convert that data. So I have electricity consumption like 1 kilowatt hour in unit. How I can convert into CO2 equivalent? So for all such material and activities, there will be the data called conversion factor, emission conversion factor. So once you find that emission conversion factor, you just multiply that given factor with respect to the activity data. Like if you are having electricity as 1 kilowatt hour, you choose the appropriate conversion factor for the electricity, multiply it, that's it. That's the final number will be in terms of kg CO2 equivalent. This much amount of kg of CO2 this particular activity has contributed, like that, right? So then likewise you calculate the emission factor based multiplication for all the material input, energy input, waste output, emission output, then sum up all those things, then finally you will get the total embodied carbon. So finally, in case if your emission factor comes with not CO2 CO2 equivalent but CH4 equivalent or some other CFC equivalent, GHGs, lot of GHGs are there, some 7 or 8 prominent greenhouse gases are there, right? Sometimes the emission factor comes with respect to different gases, right? Different GHGs, not only the CO2. At that time, you have to normalize all those things with respect to CO2 because the universal representation of your carbon footprint or GHG footprint is in terms of kg CO2 equivalent. So that is the reason behind why we take CO2 as a threshold all those things I don't want to discuss that. So that's a different concept, GHG accounting and all. So in terms of CO2, we have to normalize the results. So that's the entire process of embodied carbon. So here is the simple example of M20 concrete mix. So what's the concept? Material quantity multiplied with carbon conversion factor. That is emission conversion factor, you can say. Finally, you will get embodied carbon. So from the left side, you have the ingredients of M20 concrete mix. It's a predefined one, right? So cement 320 kg, fine aggregate, sand, gravel, water. Water is there, right? So in the right side, we have the carbon conversion factor. The cement 0.82 kg CO2e. This is the factor for cement. Then fine aggregate, that's the factor, emission factor. So you can understand how it is represented. Kg CO2 equivalent. It is directly in the CO2e equivalent only. It's not in some other GHG format. So coarse aggregate and water negligible. So here we may have a question whether water has embodied carbon or not. Anyone can answer whether water has embodied carbon or not, because we have already discussed what is embodied carbon. Can anyone? Whether water has embodied carbon. I mentioned here it is as negligible, but the question is whether the water has embodied carbon or not. Am I audible? Lokeshwari ma'am, am I audible ma'am?
Yes, yes, you're audible, audible.
Okay, fine. So the thing is, universally accepted fact is water is naturally available everywhere. That is the assumption we have regarding the embodied carbon calculation, especially for water. So there is no like extraction, there is no like transportation, nothing like that. Wherever you are, you can simply put a bore, you can get the water. But you can understand there, some installation of borewell is there, some energy is being spent, and whenever you want to have a water in your tap, you put water on and gets filled in the tank, then only you are getting down in the tap, right? So water still has some embodied carbon with respect to its operational energy, but most of the cases, for very basic calculations, we don't include. Why? Because normally what we do, for example, here you consider the given example, cement we have as 320 kg as a baseline case, as a regular case. What we are trying to do now with the cement, we want to try the embodied carbon of that cement by replacing some quantum of cement with some other material, usually, right? Similarly, fine aggregate, coarse aggregate, there are some alternatives we used to check. But with respect to water, there is no such alternative, right? So, anyhow, in your existing condition, you are going to use the same water. In your proposed modified or improved condition, also you are going to use the same water. So, by accounting such energy requirement or embodied energy requirement for the water, in both the cases as the equal value, we can ignore that. So, that is why it is being negligible here. It doesn't mean that water does not has embodied carbon. It has. But by calculating all those energy for water, there is no meaning. Because in both the cases, you are going to calculate the same value. Since both the side you are going to use the same value, same input, so that you are ignoring for the comparative life cycle understanding, right? So finally, multiplying all those factors with respect to the quantity, you get total embodied carbon of this concrete mix is 316.4 kg CO2 equivalent, right? So this is how it is being done. Now you may ask where I can can access or where I can have all those emission factors, because that's the thing here, right? So we have major source of embodied carbon conversion factor as inventory of carbon and energy. So it's a open source database which is available in this particular website, Circular Ecology. You may note down this. It is open source. It is UK based organization. So they are taking responsibility for coming up with embodied carbon factor for major construction materials. So in this site, if you go down, you have to fill all these details. No payment, nothing. It is free. Then if you download, it will download. That's all. So and this is how it will look like. Yes. This is the Excel sheet, obviously Excel sheet. You will have all the major construction material starting from aggregates, right? So if you see for the aggregates, this is the material, right? So I can zoom aggregates and sand. So UK based general data, right? So sorry, UK based general data. What's the embodied carbon? 0.00747, right? Similarly, you will have different sort of aggregates and the respective embodied carbon. Sand, based on the sources from where the sand has been sourced, based on that different values, right? So it's being mentioned with the different material characteristics as well. So similarly, you can have aluminium, because aluminium is very high embodied carbon metal. Then asphalt we have. Almost everything. This is why, that's why it is called inventory of carbon and energy, right? So for whatever your projects or research papers, articles, you can derive the factor from this particular database, and you can cite this source as well, right? So for the civil engineering, this is a kind of a very great resource. Clay bricks, and then concrete. Concrete, we have different options, right? Like partitions, we likely partially replacement. So here it is mentioned like replacement with fly ash, 15%, 30%, 40%. What would be the respective embodied carbon? So those all these kind of things will be there, and the precast concrete numbers also they would mention, for precast concrete model, like like unit concrete, ordinary Portland cement concrete, at the top 300 kg per meter cube of concrete. So they would mention the unit as well. So based on that, you can divide it by that or multiply to arrive for your respective this. Then glass, we have glass, very important. Then steel, obviously. But we have recycle, high amount of recycling, up to 99% of steel recycling is being happened in India. So steel is not so a big issue these days. Recycled steel has arrived. So timber, finally, we don't use timber majorly, but still, our certain climatic regions in India, like northeast, right, northeast, and some hilly zones, still practicing timber-based construction. So there, these data would be highly useful. So from here, you can cover up these conversion factors, and you can calculate the embodied carbon of your particular product. Because we can't, we in our UG projects, we talk about replacement of this with that, that with this, like all those things, but we never mind about what's the embodied carbon of our proposed replacement. The proposed replacement should be aimed to reduce the carbon footprint. That should be the ultimate aim, right? So we simply mention as it's a waste management. Yes, fine, but still, for example, I would say recycled plastic is having more embodied carbon than the virgin plastic. That's the worst scenario, right? So we should understand what are all the processes that are underwent to make a product environmentally friendly. We should not blindly think every waste when you use it will be reducing carbon. No, it is not. Right? So that only we should understand the embodied carbon. So that's the ultimate benefits one can get by the understanding of embodied carbon. You can reduce the carbon footprint. You can comply with the regulations and norms for the certification, because if you take about green building certifications, especially lead US based lead certifications, so they are highly cautious about what is the carbon footprint, how you reduce that, in different ways. They are highly, cautious. So for compiling and to achieve certain level of certification with respect to lead, you have to calculate and understand about these embodied carbon. Then obviously cost savings in some areas. Then market advantage is there. Market in the sense from the perspective of the manufacturer. So if you manufacture brick, there would be some 10 different manufacturers of brick would be there in a country, in your locality. So among from all others, if you understand how the carbon is being there within your produced brick, accordingly you can claim your marketing point of view, right? We are low carbon brick. We are, carbon zero brick. We are carbon negative brick. All those things you can do, right? By understanding the embodied carbon. Then obviously innovation and leadership, it would help in, we can incorporate different materials on our table, and we can make composites with different combinations based on their embodied carbon, so that we can, who knows, we can come up with some innovative material, right? Then stakeholder engagement through transparency, which means if you are run a business producing some product, all your investors and stakeholders would be accurately informed about what's the carbon footprint of your product. Like, no, my carbon is this much value. Like if you are coming up with to the specific number of carbon as a metric, people would automatically have more faith in your product. But what we come across is greenwashing practice, which is nothing but eco-friendly, green friendly, or earth friendly, green product. Simply they would use the term vaguely as eco, green, all those things, without deliberately sharing the information on the exact metrics like carbon footprint. Those and all are called as greenwashing, right? Like brainwashing, we term it as greenwashing. So against such greenwashing, Indian government has released, strict regulations from the perspective of consumer rights, right? Economics and commerce department have released some draft guidelines. So how not to do greenwashing with the products. So this is open to all the product manufacturers in India, right? So India is already started taking actions against such greenwashing. So wherever you see some green, you please try to look for some number, that kg of CO2 equivalent, like that. If it's not there, it is fake green, right? So that's the ultimate understanding you should have. But with respect to whatever product, it is a steel or a cement or concrete mix or brick, you may come across all these kind of things, like vague claiming. So that should be supported with that proper carbon based metrics. It is very important. Then evaluating carbon. So for this we have different tools. We have a software based tool. Very importantly, we have a one click LCA. Why one click LCA alone? Am I audible? Am I in the meeting? Yes, fine.
Yes, sir. You're audible, sir.
Yes, fine. So one click LCA is the like our Reliance, right? Reliance in India, how they are dominating the telecommunication business, right? Similarly, this one click LCA is dominating the global market for the construction sector. So what they are doing is they are providing the entire whole building life cycle analysis tool within their one-click LCS software, so that no matter you construct a building in America, UK, or in Japan, or in India, you have to use only this particular fellow, because there is no other competitor in the market. Recently, one other product is getting rising to to make a clash with this global dominant, that is called carbon wise. That is another building LCA based software tool. So both are almost looking similar. I have used both of them. I got a demo for carbon waste couple of months back. So they are actually, this only Kelsey is from Netherlands or Finland, I think, at the origin. That carbon waste is surprisingly from IIT Madras alumni, right? So he's the founder of that carbon waste, but still he is struggling to get the market, because these only LGs keep on getting expanded day by day with respect to their features. So with this particular one-click LCA software, we can do the building LCA from the very start to the ending point. So before the arrival of one-click LCA, how the life cycle assessment was perceived is like a complicated operation. We have to learn Sima Pro, or we have to learn Gabi, or we have to have a separate dedicated skill for doing such LCA. It was the initial opinion, but after the arrival of one-click LCA, it has all become automated, like AI based automated. What we have to do is we have to supply the material based data. This material, this much amount, that's all. Like once you complete the Revit model, you can able to extract the material quantity, right? For the block, for the wall, this many bricks you need. For the concrete, this much meter cube, or this much ton of concrete you need, like that. Bill of material, people used to say. Like in a estimation subject we used to have, right? Final quantity of material. So that quantity of material only we should have, and if we feed into this software and choose some methodologies and all those things, then automatically it will generate the result within a fraction of second, right? So that is how one-click LC can be used in evaluating the embodied carbon for an entire building, right? Then we have other small calculators here and there, web-based calculators and some software-based calculators are there. One among the thing is, from circular ecology, we have embodied carbon model for concrete. So with this, you can design, or you can understand what is the carbon footprint of your proposed concrete mix. We used to do some modifications, right? Like instead of cement, I used this. Instead of fine aggregate, I used this, like that. So different combinations you may go for, and more composition difference you may go for. So for all those things, you can use this particular concrete. You just need to put the material based input, like what material, how much amount you are going to use. So everything will be there. You just need to fill the gaps, and if you press calculate, the total carbon footprint of that given mix will be displayed, right? So this thing can be used. It's a free tool, open source, as I mentioned in the same circular ecology. You can put it in the Google, it will directly um, uh, lead you there, right? Then we have Carbon Designer 3D, which is a subordinate feature of one-click LCA. So this is where we can do some trial and error before starting the actual designing process. So now only we are reaching the topic of our session, yearly design optionary, right? So this is where we can do that. So I'm not going to explain this. We are directly going for the tool demonstration. So in the meantime, anyone have any questions, you may please ask. The demonstration will be completed shortly. In meantime, if anyone have any questions, I hope no. So fine. So this is the one-click LCA tool which I am taking care of. So all these projects we completed, right? So this one is the recent one. It's a Chennai-based building, right? A new building design. So this is the final result. I already completed this. This is the final result. So normally what we do is, if you see this, I hope the screen is clearly visible, right? Fine. We establish the baseline condition first. Then from the baseline condition, we improve the material selection in terms of proposed condition. So if you see the numbers, baseline 26 something, it is 12 something, right? So it is reduced carbon. In the picture, if you see, it is the baseline, it is like 345 kg of CO2 per meter square. It is like per grass floor area, it is showing the value. You see the proposed, you can understand it is 164, right? We have reduced, and this is the global level threshold values for office buildings, sorry, data center buildings, right? Because this particular project is a data center in Chennai, and you can able to see the graphs. All those things are there. So fine. So here we have Carbon Designer 3D, right? So if you click that, it will show LCF or Lead International CML. So that CML is actually a methodology for life cycle assessment. You should understand, right? Majorly meant for building based LCAs. Different methodologies, impact assessment methodologies are there in LCA. This is CML, which is being practiced for the international case. So you have to click that. It will come out, and I have already made some two practices. Let's create as a new one, right? So this is actually within the existing project. You should understand, right? So design name, we can have control yes, baseline 3, right? Already 2 is there. So what is the reference building? We have options, different options based on the location. So if we are not having any specified location, we have to choose international reference building, right? What's the type of the building? It is office building, right? Or data center, right? So if the data center is there, you can choose data center. Yes, finally is the data center building, because data center buildings are meant for high energy consuming and high heat emitting building, right? So that's not the typical office building. So calculation period normally is meant between 50 to 60 years, like the design period of a building, right? So that's the standard number we used to give. Then we have the scope definition. What are all the components you want to consider within your building? So now understand, now you are in the place of very, very earlier phase of your design. You have not yet started your designing for for a building. Even before that, you are using this. Now, please understand in that sense, right? So we have foundations. We don't have ground slab, because ground slab is meant for underground floors, right? In case if you have underground floors, you have to choose this ground slab. So how many floors above the ground? 14. As per this particular building, you can choose whatever the number is. Underground heated floor, is there means you have to put else 0. So if this 0, you can untick the ground slab. Just a minute, just a minute. Let me come back. Is it audible? Sorry.
Yeah, you're audible, sir.
Fine. So if you don't have the underground floors, you don't need to give the number. Then what is the structural frame? So we have different options: concrete cast in situ, column being based, or completely precast, or steel, or even timber column. All those things are there. So based on your choice, your location, you can choose that. So this one concrete in situ, very typical, right? Column spacing 7.5 meter is there. Still, you can modify later. Then this is actually for visualization, not the actual. We are not going for piles. It's like for visualization. You would understand, right? So under that you have foundations. Whether you go for secant piling wall or soil stabilization, it's like depending on your that field condition, right? Let's go for soil stabilization. Before constructing, you may need to do the stabilization. So consider that, right? So the next thing is, here is the geometry of the building. This is the visualization, right? So under that you can able to see some sticks that are for the visualization of foundation. They are preferring the piles. So that the length of piles only they asked in the previous section, right? So that is only for visualization. So height above the ground, depending upon the floors, you can choose that. Width, normally it's not the typical width, so we can reduce that. So it's like a box. So it's and all based on your intended design, right? So how much area you have, how much built environment you want, all those things. Then depth is nothing but actually it's like the thickness, right? This thickness value, this depth value will affect the column spacing distance, right? That's the meaning. So if you keep on reducing, you can understand the visualization. Height and width remain constant. Only the thickness, gets changed. So based on your site availability and the conditions, you can choose this. Everything is editable, right? So internal floor height. So 5.8 is huge, right? So internal floor height. Yes. So they are having different numbers. So for the given building, if you are keep on increasing the floor exceeding the building, right? So you can keep it as smaller one, right? Fine. 5.8, huh? It was there. So what's that? 5.8. Okay, fine. So column spacing, we already chose that, but still we can reduce or modify here. Uh, then number of staircases, if you want more, you can put more. Then the total grass floor area, we already gave us prior input. In case if you still have different value, you can put it here. Let's round it off like 75,000, right? 75,000 meters square. Additional building dimensions. So all these things are purely structural based. Uh, During the prior design stage, if you have the values of these things, you can use, but still it is already filled with the default values. So the ultimate objective of using this carbon designer 3D is, before going for the actual design of your project, from the foundation to the top, you want to visualize how much carbon it would be considered, basically with the fundamental options like envelope thickness, all those things, window ratio, balcony ratio, all those things are there, right? If you don't want to update all those things, you keep as it is. Now once you provide the geometry, you click calculate areas. Immediately the areas has been calculated. Because with the area, the quantity of the material will be put up, and along with the emission factor, it would come up with the carbon emission values, right? So that's the concept. So in the structure, in case if you have still further modifications for your areas, you can modify here itself, right? So soil stabilization is actually meant for these much areas, right? Then cleanliness areas is nothing but that DPC damp proof course, and enclosure is there. Finishes like wall finishes and services. So everything remains, equal thing. In case if you don't want such a certain provisions, I don't want to do any elevators means you can remove the elevators and all those things. Like that, you still can, make fire suppression in the sense a certain segment of your building would be meant for fire resistant compared to the other parts. So, what about those areas of required things you can modify here, like not 75,000, some 10,000 areas alone. I want to have some high fire profile. So once you finalize these areas, then now you can click the next, and it may ask a template. If you don't have a template, normally we don't have a template. You go for individual practices, then submit. So the calculation is happening, and we are going to get the carbon footprint of our designed product. Yes, just a second. Yes. So this is the carbon footprint of our given design. So you can able to understand what are all the components contributes to the carbon. So foundation, soil stabilization being one of the very major carbon contribution. So now you can understand for the entire area of your building footprint, if you want to go for the soil stabilization, or whether you can limit that stabilization activity within certain regions, like that you can now think upon. So total carbon 610 kg per meter square. That's the value we are getting for the given value. So from the carbon view, you can understand, right? Like everything is green. The slabs are putting like orange color, which means they are, floor slabs. You can understand the left side. Floor slabs contributing more. Then we have electrification, ventilation, floor finishes. We have, then columns, beams, staircases. So everything is having certain things. We can have by material also. Ready mix concrete, contributes the top. Second thing is HVAC components, right? So earlier we chose all these things, then only it has been considered. If we don't consider only foundation, if you take only for the foundation, it would represent here, right? So at the bottom, if you come down, first of all you have the foundations. So for the given data for the above information, this is the detailed breakdown component wise, right? So we consider about the foundations. Now we want to modify this foundation options, right? So now you can edit. So regarding this particular input, this 77,705 meter square is meant for the actual foundation. Now if you click this show unused resources, you can have the different options for the foundations. Different options. So what are they are having? Footing foundation for bedrock or gravel filament per grass floor area. Include points and strip footings. Like this, we have different footing options or foundation options. Randomly here, rammed concrete piling foundation for hard soils, same rammed concrete piling foundation for soft soils. So within your chosen site, you may have different segments. Some cases, certain portions may have hard soil, soft soil, all those things you can understand from the earlier site assessment, soil assessment. So based on that, you can choose these two different options. Like now the entire 100 percentage is this particular thing, footing foundation for hard soils. This is the existing phenomena, and total carbon is 610. Now we want to explore what the different option contributes to the carbon. Now, for example, let's go for this same for hard soils, the piling, right? The steel core piling foundation for hard soils, right? Now you can remove the percentage, 50 percentage, and here you can change that is getting updated. Now this has to be changed 50 percentage. So now if you come up, you see it is 688 kg per grass floor area. So which means it has increased even some 50 percentage of steel piling, steel core piling contributes to more carbon. So we can't able to go for 50 percentage. So let's go for 25 percentage instead of 50 percentage. Now you change another 25 percentage with steel core flooring. Then we may choose rammed concrete piling as some 25%. Right? So three different options instead of two. We have so now we have 653 kg. Right? I hope you can able to understand 653. Earlier it was 688. Now it has been reduced to 653. And obviously the material based component also getting changed. Right? So foundation you can understand. Right? So like this, we can still go for very peculiar different option based selection of foundations. So we have like soft soil instead of hard soils. We may sorry percentage 50 percentage soft soil. So you forget about the steel piling and all those things. We have only hard soil and soft soils like that. So the percentage has to be tallied for the 100 so that only it shows red indication. So now we have the footing for soft soil some amount and hard soil some amount, strip footing basic, right? So now it is 642. So earlier it was 610, the very first thing. Now it is 642. Likewise, if you keep on, iterating with the different options, because in each option the depth would vary and the material would vary. So how much amount of depth you go for the piling would vary. Like you have up to 10 meter minimum. A steel core piling is 10 meter, maximum is 50 meter. So for different depth, also you can understand how it contributes to the actual carbon footprint. So is there any question? So I hope this is how yearly design optioning is being done for the carbon efficient foundations, and this is one of the tool. I hope this would be the major tool that anyone can have, because this addresses component by component. I can say no other tool can address in this precise manner. So we don't worry about the other components. We can only work on the foundation alone. So once you complete the foundation, then you can finish editing the foundation. Then you can move upon soil stabilization. In soil stabilization, you have four different options, right? So sheet piling with 30 meter depth with 15 meter depth, soft soil, hard soil. So there also you can change some modification and you can understand how it impacts the total carbon footprint of your project, right? So if you come out, we have what chat GPT say has to say for the same question, right? So let's check, because everyone can't able to have such a tool, right? Paid tool. So we have chat GPT. It's open source, and we can ask the same question, right? So the thing is, we have to give the proper prompt, right? Start with hi. Okay. So I want to uh, understand the impact of my foundation choices for a G plus 4 data center building in Chennai. I do not have any emission factor data. You refer the industry average data and show me carbon footprint of different foundation options for a given building. So when we give such prompt, it comes with the answer: traditional slab on grade foundations, waffle slab foundations, pile foundations, and rat. So it doesn't talk about the numbers, right? I want carbon based metrics for the above choices. So now it calculates, right, for different options. Like traditional slab on grade, we can have carbon footprint found. It shows only for the foundation areas, right? So for traditional slab on grade, it is 160 to 250. It can't able to calculate the exact figure because we don't have the emission factor. It is working on their own database. So let's okay table it fine. So for the foundation type, traditional slab, the carbon footprinting is 160 to 250. Waffle slab 90 to 160. Piles and raft 300 to 500. So we can understand waffle slab can be a better option by this particular output. Now we have to discuss this with the actual, the particular expertise, and we can understand the possibility of going for that particular foundation for our given building. So this way also you can do the same activity with the help of ChatGPT, but you should be able to give and you should be able to interact with it accordingly so that you can able to get what the exact information you want to generate. This is free, right? So one click LCA is $5,000 per year. ChatGPT is free. So, but the accuracy level differs. But still, the early design optionary, the ultimate objective of it is the visualization of carbon load. That's it. With this ChatGPT result also you can visualize, right? We can differentiate the foundation options. Then it's a win for us. So by this way also we can do this, but still it is highly recommended to go for the emission factor based calculation. So as I already mentioned, emission factor is there in ICE, inventory of carbon energy. You extract the respective data, make a table, and from the table you input to the chat GPT. These are the data I have, emission factor. Using this, you calculate now. If you feed, it would come up with more refined and precise values. That's the difference, right? So I hope we had a good things. So these are the key takeaways. So decarbonization has multiple routes, and the understanding of embodied carbon is the very first step to begin the decarbonization of built environment. Then embodied carbon can be calculated by multiplying the emission factor with the material quantity. Then databases of embodied carbon, we have open source and we have web-based application and softwares. And from software to web applications, anywhere we can able to see it is Western world dominated data only we are having, especially with respect to Asian continent, we don't have, especially with respect to Indian continent, Indian context, we don't have. So that would be the major drawback and limitation currently, but still continuous realization of LCA based values and EPD based values for the manufactured products, we can contribute more databases from the Indian context also. So that would help in filling up the gap, right? So I hope I have delivered what I was intended to. Is there any questions, feedback? You can share now.
Thank you, Mr. Saravanan. Thank you. Participants, now the forum is open for discussion. Sir, I want to know something.
Yes,
You
ma'am.
were talking about the lead certifications from your company and things, right?
Yes, ma'am.
Yeah. How would that be? Uh, how would that be good for a faculty? How would it be profitable for a faculty in terms of teaching it to the students?
Actually, in USGBC, we they have USGBC accredited faculty recognition. So for that, what they are doing, they are actually having different green credential, starting from lead green associate, lead AP for different project levels. Just like how we are having IGBC accredited professional in India. In IGBC, they are also offering IGBC accredited faculty as well, right? So same way USGBC function. If you have any one of the green credentials which are offered by USGBC, starting from lead green associate to whatever the different accreditations, once you have that, you can apply to become USGBC faculty. For that, they charge $500 per year, which is around 40 to 50,000 for us. So what it gives is the power to teach the lead-based green building strategies and principles to anyone that you want to teach. Right. So that's the ultimate recognition they provide. So if you go there and get some lead GA or lead AP first, then you apply that and you get there is no shortlisting nothing. Once you get any lead credential,
Mm.
you pay and apply. They will approve you as a USGBC faculty. In India, I would like to add upon in India, very few, 2 to 5, less than 10 USGBC faculty alone are there in India. And very importantly, there is no one from education institution. They are all
Oh,
industry, industry people. So they teach corporates to corporates, right? There are
okay.
nowhere people teaching students. So if you become one, you will become very few in India.
Okay. Thank you, sir. There is one more question in the chat box, sir.
Yes, ma'am. Please, ma'am. It's in the chat box. I think I can start
Stop presenting.
something.
Yes, yes,
Yes.
you can stop.
Can we change the superstructure despite of building to bridge in the one time one time LCA in the sense? Can we change the superstructure? Actually, this one click LCA is meant for buildings, right? And what I told is all you need is the bill of materials data. So with that bill of materials data, no matter you construct a building, no matter you construct a watching tower, no matter you construct some elevated water tank, it will give the answer, right? But the methodologies we have for calculating the impact is actually categorized for building typologies alone, right? So we don't have any what to say, life cycle assessment methodologies for bridges or some kind of infrastructure element, because you understand buildings are more in number than the bridges. So that's why they don't talk about the bridges, they don't worry about bridges, right? So that's the reason, and that would be the answer, I think. You can't have the different infrastructure element in your one click LCA. It's all about building typologies, because we concern, because people concern more about buildings because they are more in number and they are increasing more in number.
Okay. Any other questions from the participants' side? Well, if there is no other question, uh, heartfelt thanks to Mr. Saravanan for for his nice presentation, and you stuck on well within the time also, and you
Thank you, ma'am.
elaborately
Thank you,
gave
ma'am.
a walkthrough through the entire software and processing. Thank you, sir. Thank you so much.
Thank you, ma'am. Thank you, ma'am. Thank you for the
I thank the
opportunity, ma'am.
participants also. We can meet in the afternoon session. Thank you, everybody. Thank you.